Welcome back to our Chapter 2, Basic Concepts of Derivatives and Their Applications. Now let's have Section 2.5, Application of Derivatives. First, Derivatives Optimization, and this is our Part 2. Our learning objective is to apply the first derivative test to determine the maximum and minimum or minimum values of the formulated model. So this is a continuation to the previous discussion. Now we have the definition 2.5.3, and it talks about absolute and relative maximum and minimum of a function. Here, the first one, the function f has the absolute maximum value f of c at a number c in the domain df of f if for all x is an element of d of f or the domain. And then f of x is less than or equal to f of c. On the other hand, f of c is the absolute minimum value of the function f if f of x is greater than or equal to f of c for all x is an element of the domain or d of f. So in short, absolute maximum siya if sa f of c at a number c na domain, ato lang balikon, is f of x is less than or equal to f of c. So mas dako si f of c, so that will be our maximum, absolute maximum value. And then on the other hand, if our f of x is greater than or equal to our f of c, so our f of c is the absolute minimum value. Now for the second definition, we have the function f has the relative maximum value. So take note the word relative. So later we are going to differentiate between relative and absolute. So here relative maximum value f of c at a number c is element of an open interval AB. So it talks about open interval. Here we talks about the domain. If for all x is an element of the open interval AB, f of x is less than or equal to f of c. On the other hand, f of c is a relative minimum value of the function f if f of x is greater than or equal to f of c for all x is an element of an open interval AB. So when we say absolute, that is a big difference with the relative maximum. So here we talk about the domain. Here we talk about the open interval. So we are going to talk about more later about the absolute and the relative, the maximum and the minimum. So here, the word global may replace absolute. So in this lesson, yung word nga global, re-replace natin sa word na absolute. That is in the definition 2.5.3, we have the word absolute minimum and absolute maximum, while the word local may be used instead of relative. So now we can distinguish the difference between these two. Furthermore, if you ask to determine the extrema of a function, what does it mean? It means you have to determine if the function has a maximum or a minimum. In the case that there is only one maximum or one minimum, we call it as extremum of the function. Also, take note of the articles used to describe the respective definition. So first is the word the. So here, we have this one, the absolute or the absolute. So what does it mean? The absolute, the word the preceding the word absolute means that should exist. That should exist. Then it is unique. However, we have the word a preceding the word relative means there can be several extrema that vary from interval to interval. So in the difference between absolute and relative, for absolute there is a unique. That's only one. But however, in relative, when you're talking about this one, the extrema can be several and it can be vary from interval to interval. Therefore, a major difference between two sets of definitions is that the absoluteness of extreme values is taken over the relativeness of extreme values is confined only on some open intervals. So here we have example for letter A, the quadratic function f of x equals 4 minus x squared. So it opens downwards. This is the figure. Nag-open siya downwards. And the vertex is 0, open interval, 0, 4. So this is the vertex part, and that is 0, 4. That is our vertex. And this is the maximum point of the graph. As you observe, this is the maximum. Ito yung pinaka-max na abutin ng graph. 4 is the maximum value of the function, since this is true over the entire domain of f. So if you are going to substitute any number to this x in this f of x equals 4 minus x squared, yung pinakamalaki na number na magre-result, it's only 4. That's why that is our absolute maximum value of f. So we have the word maximum. So it's unique compared to relative. There are many extrema, but here for absolute maximum, we have only one, which is 4. The value of 4 is the absolute maximum value. So however, note that 4 can also be a relative maximum value of f. So this is a consideration with regards to the relative maximum value, as long as a proper defined interval containing 0. So this is the condition. Pwede siya for relative maximum as long as it is properly defined open interval. So kaganina we talk about interval to interval. And it must containing 0, which is the abscissa of the vertex. Yung vertex natin is 0, 4. And 0 is our abscissa. So thus on the intervals negative, open interval negative 1, 1, here x, it includes 0. For negative 2, open interval negative 2, 0.5, 0 is included. Open interval negative 1 over 3 and 3, 0 is also included. Can be an element. And negative 10 and 5, 0 also is an element on this interval. So 4 serves as the relative minimum, since 0 is included in its interval given. Rather, 4 serves as the relative, that is not minimum. Instead, this is maximum. So why is it relative? Kaganina, we talk about absolute. It is relative because it contains a lot of extrema. When we talk about uniqueness, here, in this example, we have only one. That's why we have the absolute maximum value of 4 of this function is 4. Pero, if properly defined yung open interval containing the abscissa, which is 0, 0, 4, tapos yung mga intervals ito, this one contains 0, it's an element. This one also, yan. So 4 serves as a relative maximum. Therefore, 4 is the maximum, 4 is maximum, 4 is maximum. That's why it is relative maximum. Since 0 is included in its given interval, f of x is less than or equal to f of 0, which is equal to 4 in this interval. So any other open interval not containing 0 will not produce a maximum value. So pag wala si 0 in that interval, we cannot produce a maximum value. So furthermore, since the graph of f continues to go down, so as you observe in this graph, it continues going down, right? So what happened? There can never be a minimum value. So this suggests that such can happen, that is, no maximum or minimum value may exist for a function. So we have here the maximum, but we don't have the minimum value of the function. So that is our example A. Now we have B. The absolute value function, f of x, is equal to the absolute value of x minus 2. Has an absolute minimum value, 0, since over its domain of real number. So here we have the absolute minimum value, which is 0. F of x is greater than or equal to f of 2, which is equal to 0. So as you observe, if you are going to insert, for example, f of 2. So 2 minus 2, the answer now is 0. So restricting the coverage from the domain to any open interval containing 2 will make 0. Kung imo siyang i-define ang mga interval nga may nag-contain ng 2, ang atong 0, mahimo na itong relative minimum. So that is the same with the previous example. Mahimong relative maximum value si 4 if yung intervals it contains 0. Here, pag contain naman si 2 on each intervals, so 0 will make a relative minimum value. So in this case, we do not have the absolute maximum as you observe since the graph is continuing or continues to go up on both sides, either leftward or rightward. So there will be no relative maximum values since no matter what open intervals is chosen, no value for C will satisfy the definition. Now for letter C, the function f of x is equal to x cubed. So here we have the word neither absolute maximum or minimum values. So as you observe, the graph goes downward to the left and to the right it goes upward indefinitely. So there will be no relative extrema for the given function. So hindi natin ma-determine kung is it maximum or minimum. Kasi yung both side, yung isa pababa, yung isa pataas. So we do not have a relative extrema, or we don't have the absolute minimum or maximum values or the relative one. So if you are going to compare this graph to the previous two examples, very different. Letter D. Consider the function f of x equals x plus 1 if negative 3, or the x is greater than or equal to negative 3, and x is less than 2. And f of x equals 5 minus x if x is greater than or equal to 2, and then x is less than 5. So this is the graph. So this part, this is an indicator of a closed interval. Here is the open interval. We have the function x plus 1. Here we have 5 minus 1. So dito sila nag-meet in that part. Right? So based on this graph, we can determine that there is an extrema. So from the graph, note that the function has a low point. Ito yung pinakababa na point ng function. It does not extend. It ends at x equals negative 3. Here, that is the low point of the graph. And its high point, ito rin yung high point. Diba? Yan. So, klaro. So, the domain of f is, yung domain niya is closed interval here, tapos negative 3, and then sa pikas nga part, this one that is an open interval, that is 5. That is our domain. So, the values negative 2 and 3, ito, negative 2 at saka si 3 in relation to this one. They are the absolute minimum. This is minimum, and this is our maximum values. So, defining any open interval that is a subset of the domain containing 2 makes 3 a relative maximum value. Pag ang interval naa ang 2, so himo na to si 3, mahimo si 3 og relative maximum value. Why? Because there are a lot of intervals. If you are going to contain 2 as one of the domain on that interval. So si 3, hindi na siya magiging absolute, magiging relative na siya. However, there are no open intervals which are subsets of D of F that contain 3. Sa PCAS, nga side in terms of the relative minimum, wala tay value diha nga domain, subset of domain nga na ay 3. Therefore, negative 2 cannot be a relative minimum value. So in this case, it's only 3. We can have the relative maximum value. But for 2, it cannot be. Because the domain of the subsets does not contain 3. In this case. So here we get the interval, and here we get the maximum and the minimum part. Now for theorem 2.5.2, the first derivative test, if C is a critical number, so this is based upon our previous discussion. We talk about critical number of a function f. Then f is said to have a maximum value, f of c, if the derivative of x is greater than 0. Take note ha. Maximum value if f prime of x is greater than 0 for all x is less than c. Or we have the next one, and take note, we have the word and. The derivative of x is less than 0 for all x is greater than c. So this is the two conditions. And number 2, f has a minimum value, f of c, if derivative of x is less than 0 for all x is less than c. So compared to the previous one, ito greater than, ito less than. This one less than, ito greater than. Here, less than siya dire, less than po diha, and greater than dire nga pikas, greater than po. So that is the minimum value. This is the maximum value. So the theorem emphasizes the shift in signs before and after a particular critical number of a given function. So we learned that in our previous lesson that in terms of critical number is the part that the function neither increasing or decreasing. Ito yung part na hindi na makikita kung nag-increase ba or nadi-decrease si function. So that's why here we are going to use the sign before and after a particular critical number. Pag papa-increase siya, we have the positive 1. Pag papa-decrease, we have the negative 1. So when a maximum or minimum point is as the coordinate c, f of c satisfying the theorem must be given. Lastly, if we are asked what makes the extreme value true, the value of c is the answer. Ano say answer? Ang value sa c. I think we have 5 steps how to apply the first derivative test. First one, identify the domain of the function. This is the very important one. Identify the domain of the function and determine its critical numbers. Pag makuha na nato ang domain of critical numbers, number 2, subdivide the domain into open sub-intervals using what? The critical numbers as open endpoints. And di lang sila open endpoints, they're also singletons. Sets have the single elements which contain the critical numbers. Ito yung gagawin natin later. Step 3, using a method similar to the sign chart method or table of signs in solving quadratic, polynomial, rational inequalities. Set up a table consisting of columns for the functions, its derivative and conclusion. So we are going to make a table which consists of 3 columns for the functions, derivative, and the conclusion. And then we have rows for the individual subintervals, which arrange from negative infinity to positive infinity or maybe shorter. Depende po yan sa domain. Inclusive or inserted critical numbers and values that give asymptotes. Step 4, use a test number in a particular subinterval and substitute it to the derivative. Asan isa-substitute? Dun sa derivative po. Get only the sign of the result and place this in the corresponding entry where the derivative column and the subinterval row meet. Perform this for all subintervals regarding the critical number. Simply, for the critical number po, lalagay po natin yung 0 or undefined. Dalawa lang. It can be 0 or undefined in the corresponding row, column, entry. Step 5, observe the results of the sign within the intervals before and after each critical number and interpret them using the first derivative test. Make the necessary conclusion, can be increasing or decreasing, maximum or minimum point value, and etc. So those are the 5 steps to apply the first derivative test. Now let's continue to consider this first example. Consider the polynomial function f of x is equal to x cubed minus 3x squared minus 2. And we need to follow the steps as indicated in the first derivative test. For step 1, we're going to get first the domain. And we know in this given function, the domain of the function is what? All real numbers. And to determine its critical numbers, we get first the derivative. So f of x is equal to x cubed minus 3x squared minus 2. Kunya ang yan derivative ana is 3x squared minus 6x. Then equate the derivative to 0 to get the critical numbers, diba? We have the common here. Ayan. So we have 3x equals 0. And we have also x minus 2 equals 0. So x equals 0. Here is x equals 2. So these are critical numbers. So this is step 1. Step 2. Ang step 2 is we need to subdivide. So the domain, the denominator is the real number, can be subdivided into the following subintervals, points, and singletons. So here we have 0. Here we have 2. And that is our critical numbers. Okay? So subdivide natin. So at the center, yung dalawa, 0 and 2. Here we have the negative infinity, tapos 0. Here we have 2, and then positive infinity. So inana lang pag subdivide. So step 3 is we have the table. Okay? So kaning atong sub-intervals mo nato ibutang ito, butang nato diri. So we have negative infinity and 0. We have 0. We have 0 and 2. We have 2. And then we have 2 and positive infinity. So that this is based on what we did here. Ibutang lang nato. And then here, substitute nato ang value. Pag insert nato si 0, so f of x equals x cubed minus 3x squared minus 2. Substitute nato, x nato is equal to 0. So we have 0 cubed times 3 times 0 to the power 2. So the answer is negative 2. Then for 2, 2 cubed minus 3 times 2 squared minus 4. So we have 8 minus 12 minus 4. So we got negative 8. So here we have negative 2. Here we have negative 8. So ito, patay buhaton diha as is lang. So according to our step 4, yung critical number simply put 0 or undefined. But here we have the number, so 0 ang nilagay natin, the undefined. Yan. Ang diri is we need to use the sign, but we need to first choose, pili ta diri, unsang x atong gamiton in between this given interval. Nga ibutang nato diri And then we have the value for, is it positive or negative. Now in this part, substitute lang nato here ang element or our c or our x, which is an element on this open interval, to this derivative. Okay, so here choose nato x is equal to negative 1. And our derivative is 3x times x minus 2. So we get negative 1. And substitute lang. Okay? So you have negative 3 times, ano yan? Negative 3. So the answer is positive 9 of our derivative here. Then next is for 0 and 2 interval. So our x is equal to 1. So I have 3 times 1. Then x 1 minus 2. So we have 3 times negative 1. The answer is negative 3. And the last, we have 2 and positive infinity. I will choose x is equal to 3. So 3 times 3. Tapos 3 minus 2. We get 9. This is 1. So the answer is 9. Okay. Here, we have positive 9. Here, we have negative 3. And then here, we have positive 9. According to the step, is kukunin lang natin yung sign. So, in open interval, negative, infinity, and 0, the answer is positive 9. So, we have positive here. For open interval 0 and 2, the answer is negative 3. So, we have negative. And then here, we have positive 9. So, the answer is positive. Take note how we need to substitute the value. Our x here came from the element, or that is in between the given intervals. Alright? Then, kung ano yung sign, this is positive, positive ilalagay. Pag negative, negative ang ilalagay. Now, we are going to make the conclusion. So, unsa may ibutang nato dire? Since this is positive, so our f is increasing. Now, since this is 0, so our f has a horizontal tangent line. Then, negative 2, based on this illustration, mas malaki si negative 2 kaysa kay negative 8. So, negative 2 is a maximum value. And then, for the next one, since this is negative, so f is decreasing. Then, since 0 na sad, f has a horizontal tangent line. Then, negative 8 is a minimum value. And last one is positive, so f is increasing. So to summarize, the relative maximum value of f is negative 2. So we have the word relative. And then its relative minimum value is negative 8. Note that there are no absolute extrema. Walay absolute extrema since the graph of this cubic function goes down as the values of x decrease negatively, and it goes up also as the values of x increase positively. So we don't have the absolute extrema, we have only the relative maximum and the minimum value. The last example, consider the function f of x is equal to x to the fourth power minus 4x cubed plus 4x squared minus 3. Let us determine its absolute and or relative extrema if they exist. Step 1 is to find the domain and the critical numbers. So the domain here, we have the real numbers, the domain. Okay, real numbers. Now we have the critical number. How we're going to find the critical numbers? Is kunin lang natin yung derivative ng given function. first, then equate natin sa 0 to get the critical number. So, derivative ani is 4x to the power of 3 minus 12x squared plus 8x. And then, factor, we have equate natin sa 0 para to get na sa critical numbers. We have the common factor, which is 4x. So, x squared minus 3x plus 2 equals 0. Then, factor natin to. We get 4x squared of x. And then, we have negative 1 and negative 2. So, now we have 3. So, equate natin 4x equals 0. Another one is x equals x minus 1 equals 0. And then, x minus 2 equals 0. So, here we have x equals 0, x equals 1, and x equals 2. So, our critical numbers are 0, 1, and 2. Then, step 2 is to subdivide. So, ang sama na to, subdivide, this is our 0. Then we get 1. Then we get 2. Okay. So, in this side, we have negative infinity and 0. Here we have 0 and 1. Here we have 1 and 2. And then last is 2 and positive infinity. So, mana nga ito mga subdivide. Ibutan na to. There is a sub-intervals and critical numbers. First is we have negative infinity and 0. Then next we have x equals 0 or 0, right? So that's the same. Then we have 0 and 1. Then x is equal to 1. Then 1 and 2. Then x equals to 2. And then last one is 2 and positive infinity. Okay? So next is here, substitute na to ang values of x, diri nga part. So our f of x is equal to x to the 4th power minus 4x cubed plus 4x squared minus 3. So our x is equal to 0, the first critical number. So we have f of 0. So 0 to the 4th power minus 4 times 0 to the third power plus 4 times 0 to the 2nd power minus 3. So the answer is negative 3. Next is x is equal to 1. Ito. So f of 1 is equal to 1 to the 4th power minus 4 times 1 to the 3rd power plus 4 times 1 to the 2nd power minus 3. To get 1 minus 4 plus 4 minus 3. So the answer is negative 2. And the last one is x is equal to 2. Here. So we got f of 2 equals 2 to the 4th power minus 4 times 2 cubed plus 4 times 2 squared minus 3. So 2 cubed is 16 minus 4 times 8, 32 plus 4 times 4, 16 minus 3. The remaining is negative 3. F of 2. Okay, so x of 0, x equals 0, we have negative 3. X equals 1, we have negative 2. X equals 2, we have negative 3. So that's all about this column. Now for the next, so according to the step, can be 0 undefined. We have the constant here, so we have 0. Right. So, ang problema na lang natin is itong portion. So, we're going to use this one. Then, mamili ta diri og unsang x atong gamiton, which is an element of this given interval. Our given derivative is this one. So, 4x times x minus 1 times x minus 2. So, manay gamiton nato. So, for the interval negative 8 and 0, we will choose negative 1. 4 times negative 1 times negative 1 minus 1, negative 1 minus 2. We have negative 4, negative 2, negative 3. We have negative 24. Open interval 0 and 1. So we will choose, I think you have 1/2. So 4 times 1/2, then 1/2 minus 1, and then 1/2 minus 2. We get here 2. 1/2 minus 1 is negative 1/2. 1/2 minus 2, we have negative 3/2. Or 1 and 1/2. So here we can cancel this one. So 2 times negative 1/2, we have only negative 1 times 3/2. We get positive 3/2. Next we have 1 and 2. Our x is 1 and 1/2 or 3/2. And then 3/2 minus 1 tapos 3/2 minus 2. So this is 6. 3/2 minus 1 is 1/2. 3/2 minus 2 is negative 1/2. So this is 3 times negative 1/2. The answer is negative 3/2. These are derivative 3/2. And then the last one is 2 and positive infinity. So our x here, we have 3. So 4 times 3. So 3 minus 1. And then 3 minus 2. We get 12. We have 2. We have 1. So we get 24. So here we have negative 24. Here we have positive 3/2, negative 3/2, and then the last one is positive 24. So in this part, for negative infinity and 0, since we have negative 24, so ang butang da is negative. For 0 and 1, we have positive 3/2, so positive ba ito ibutang. For 1 and 2, we have negative 3/2, so negative ba ito ibutang. Then for 2 and positive infinity, we have positive 24. So we have positive atong ibutang. Now let's have the conclusion. So since this is negative, so our f is decreasing. Here we have 0, so f has a horizontal tangent line and negative 3 is a minimum value. So sir, why is it minimum value? So we have negative 3 and negative 2. So mas malaki yung negative 2 kaysa negative 3. So we have negative 3 as our minimum value. Next is positive. So f is increasing. Here also we have f has a horizontal tangent line, then -2 is a maximum value. So we have negative, so f is decreasing. We have -3, so f has a horizontal tangent line. Horizontal tangent line. Then -3 is a minimum value. And we have positive, so f is increasing. Okay? So the function has two relative minimum points that give the same minimum value, which is -3. So natay duha ka minimum value, which is -3. Pero adto na laman tayo usa, only one relative maximum point, which is -2. So since the polynomial function is of a degree 4 with a positive lead coefficient, this means that as x approaches positive infinity and as x approaches negative infinity, f of x approaches positive infinity. So this translates to the fact that both relative minimum points are absolute minimum points also. That is our part 2 in this lesson about application of derivatives. So we talk about the first derivative test and we learn about more the concept of first derivative test. So we need to follow the 5 steps and we need to apply this one in order to get the first derivative test. We have still part 3 and we are going to solve problems involving this one.